Welcome everyone. Today we are going to complete a workshop on t-tests. If you remember from class, we computed t-tests by hand and we learned the purpose and the meaning of t-tests, but today you're going to learn how to do it in SPSS, and it is very simple. But just as a reminder, a t-test is a statistical test used to determine if there's a difference between two groups. There are several types of t-tests. Most often we see these types here. The one sample t-test, you'll use this t-test when you compare a sample to a population. For instance, the question here, college freshmen study 10 hours per week. Do they study more than everyone else in our study of college students? So you'll see that you get a mean score in the question, and you collect one sample to compare to the mean score. So that's why they call it a one sample t-test. The most common type of t-test is probably the independent samples t-test, where you compare mean scores on two unrelated samples. For instance, this question here, in our sample, do college freshmen study more than college juniors? So you compare essentially just two groups that have nothing in common with one another. If the two groups do have something in common, you would consider using a paired samples t-test. So it compares individuals from one sample to individuals from another sample on some related basis. You would also do this in some longitudinal data if you're looking at time 1 versus time 2 of data collection. For instance, a question here, do students study more when they are freshmen as compared to when they are seniors? So you would examine the number of hours studied as a freshman and then assess them again when they are seniors. There you would do a paired samples t-test. So just that was a quick rehash of what we did in class. So let's go through the SPSS procedures for each of these. They're very simple, and this shouldn't take very long to compute and interpret. And we'll start with the one sample t-test. So whether you're doing a t-test or an ANOVA, I kind of like to make sure you understand the procedure. So if you're doing any hypothesis testing procedure, you will want to go through a process somewhat like this. First thing you need to do is formulate your null and research hypotheses. Next, you'll set your alpha value. If you remember correctly, we usually keep that at 0.05 in the social sciences. Next, you will compute a statistical test to determine significance, so whether there's a difference between the groups. Your job here is really to make sure you choose the right statistical test. And finally, I'm going to teach you how to report results in APA format. Pretty simple. So let's get a research question here, and we'll compute some stats on it. Let's look at this. Oh, it's that time of year. Purchasers of Girl Scout cookies on average eat 5 cookies per sitting. Well, I'm not in this sample because I would eat all of them. Do participants in our weight loss study eat more than that? So do they eat more than 5 cookies per sitting? So let's take a minute and go through each of these steps in our hypothesis test here. So step 1, formulate our hypothesis. So our null hypothesis, as you remember from the last couple class periods, would be that the mean number of Girl Scout cookies eaten in our sample will equal 5, which is the mean of the population. Our research hypothesis would be that the mean number of cookies eaten in our sample does not equal 5 cookies per sitting. And you can see that in the research question. Purchasers of Girl Scout cookies on average eat 5 cookies per sitting. So we are making sure we have a non-directional hypothesis here. Just as a quick reminder, if you don't know what kind of t-test to use, remember, if you see a mean score in your research question, you are going to compute a one sample t-test. So step 2 here, set up the alpha. The alpha is going to be 0.05. We'll stick with that. That step's easy. Let's move on to step 3. compute a statistical test to determine statistical significance. So this is where we're going to use SPSS like we have been for our workshop. So let's see here. Let's open up our data set. Okay, this data set is called dietstudy.save. See up here. And the first thing you should do when you open up a data set is sit back and familiarize yourself with the data. I'm going to click on variable view down here so I can see the types of data we're looking at here. We have the names of the variables here, and we have the labels here. So we've got patient ID number, the age, gender. Looks like we have weight at 5 time periods. Very cool. So you have weight at initial weight, first week weight, second week weight, the whole way up through 4th week weight. We also have weight loss and the number of Girl Scout cookies eaten at time 1 and the number of Girl Scout cookies eaten at time 2. So here's our data view down here. You can see different weights, weight loss, and the number of Girl Scout cookies eaten. Okay, so the question here is, on average, people will eat 5 Girl Scout cookies per sitting. Do individuals in this particular sample match that, or are they different? So what I want you to do is click on Analyze, and you'll go to Compare Means, because essentially that's what a t-test does. And since you have one sample here and you're comparing it to a mean, you'll click on One Sample T-Test, and this dialog box will come up. Now, we're looking at Girl Scout. I want to look at Girl Scout cookies at time 1 here. So I'll click on that and add that in. We'll just forget about time 4 for now. So we're only looking at Girl Scout cookies at time 1. So click on that and put that into our test variable box. And you'll see down here it says test value. That's what the mean that you're comparing your sample against. So if you remember correctly, on average, people will eat 5 cookies per sitting. So enter that in, make sure everything's set up, and you click on OK. The output will pop up here. You have your results. Very simple here. So let's take a look here. We have our sample statistics here. So number of Girl Scout cookies eaten at time 1. There's 16 participants in this study. The average number is 10.81 cookies. That sounds more like me, with a standard deviation of 1.37 cookies. So you can do the eyeball test here like we did in class. Ooh, our sample eats about 11 cookies. The average person eats about 5. I would probably suspect that there would be a significant difference there. But that's just the eyeball test. Let's look at the one sample test down here. And you should direct your attention to these 3 numbers here. The t-statistic, the degrees of freedom, and the p-value, which, if you remember correctly, SPSS labels as significance. So what we see here is the t-statistic is 16.89, so that's on the t distribution like we talked about in class. The degrees of freedom is 15, and the significance is 0.000. So what that means is that, yes, because that p-value is under 0.05, the alpha that we set, there is a significant difference between our sample and the population mean. That's basically it for SPSS there. So let's go back to our PowerPoint and move on to our next step. Next step is that you want to report your results in APA format. So this is how you do it. It's very simple. Step 1, you want to state the type of test you used and what you were evaluating. You could restate your research question here. Next thing you need to do is state whether or not the test was significant, and make sure you include your t-statistic, your degrees of freedom, and your p-values. Final thing is you want to state your results kind of in non-technical language or layman's terms, and make sure you mention the mean and standard deviation. So I'll pull up here our results that we just got in SPSS, and we see here that we have our one sample t-test, so that's in number 1 above, so state the type of test you're going to use. We have our t-statistic, our degrees of freedom, and our p-value. And finally, we have our mean and standard deviation there. So you're going to want to say it specifically like this here. And take special note to how you report the statistics. This will probably be the only course where you report the statistics as such. So I say here, a one-sample t-test was conducted to evaluate the hypothesis that individuals participating in this diet would eat significantly more or fewer than 5 Girl Scout cookies. Our test was significant. The t-statistic, where our degrees of freedom was 15, is 16.89. P is less than 0.000. That should probably say P is less than 0.001 because it can't be less than 0. The average number of cookies eaten in this sample, which was 10.81 cookies with a standard deviation of 1.38 cookies, was significantly greater than 5. And that's it. It's a lot easier than doing all the math by hand, but it's very important to learn to do the math by hand so you know what these concepts mean. Let's move on to the independent samples t-test. It's just as simple. We have a new research question here. Is there a significant difference in the number of Girl Scout cookies eaten by males and females? What you notice about this question is that you'll need an independent samples t-test because you have two independent samples. You have males and the number of cookies they eat and females of the number of cookies they eat. So, our null hypothesis is that the number of cookies eaten by males will equal the number of cookies eaten by females. And our research hypothesis is that they will differ. Step 2, we'll set our alpha, 0.05. That's the easy step. Step 3, let's compute our statistical test here. So we're going to compute an independent samples t-test. So let's pull up SPSS again. Alright, we got our data set here. We're already familiarized with it, so I'll just get on with it. We'll go to Analyze, Compare Means, Independent Samples t-test. Alright, you have a similar dialog box up here. So we are interested in the number of Girl Scout cookies eaten at time 1. Now remember, we have time 1 and time 4 here. So we'll start with just time 1, number of Girl Scout cookies eaten. But our grouping variable is going to be our independent variable. So whatever our groups are, and we know that that is indeed gender here. Our research question is who eats more, males or females. So we'll add that into the grouping variable. Now at this point you'll have to do something a little different. Click on Define Groups, and you'll have to label the two groups as they are labeled in SPSS. So, we labeled females, as you can see here. As you can see here, females are going to be 0, and males are going to be 1. So I'll enter 0 for females here, and 1 for males here. And click Continue. So that's going to compare those two groups on the number of Girl Scout cookies that they eat. Very simple. Let's click OK. And we have our results here. Let's see here, we have our group statistics and we have our independent samples test here. So, first thing you want to look at here is we have the number of males and females. Okay, 7 males, 9 females. The number of cookies they eat. Let's see, males eat 10.85 cookies. Females eat 10.77 and change. They might not be too different. The eyeball test to me makes it seem like they're not too different. So, I look down here at the independent samples t-test. And what I want you to do, there's a lot more information here. I want you to go to t-test for equality of means. And I want you to look at equal variances assumed. So, you'll look here, we have our t-test, our degrees of freedom, and our significance. So you'll know here that this is not a significant difference between males and females. So now you know the results of the independent samples t-test. Let's move on to step 4, which is reporting your results in APA format. You see here that it's the same way as you do it for the one sample t-test, and it'll be the same way that you do it for the paired samples t-test as well. So let's pull up the results that you just saw here. Step 1 here says state the type of test that you use. So we have an independent samples t-test. You're going to state whether or not the test was significant, including your t, your degrees of freedom, and your p-value. You see that down there. And finally, you want to record your mean and standard deviation. So, using that, you want to say something like this. An independent samples t-test was conducted to evaluate whether men or women eat more Girl Scout cookies. The test was not significant. Our t with the degrees of freedom of 14 is negative 0.111 with p-value of 0.914. Males with a mean of 10.86 cookies did not eat significantly more or significantly fewer Girl Scout cookies than females who ate 10.78 cookies. Pretty simple and comprehensive. So, let's go to one more. We have our paired samples t-test. So if your sample is related to one another in some way, for instance, perhaps husbands and wives, perhaps you're looking at time 1 versus time 2, you'll want to do the paired samples t-test. So our research question here is, after a special diet, do participants in our study eat significantly fewer Girl Scout cookies? Okay, so our null hypothesis is going to be the number of cookies at time 1 does not, or equals the number of cookies at time 4. Just for your reference, I do call it time 4 because we're having, we had 4 measures of weight. So just for your reference. Our research hypothesis is going to be, once again, a non-directional hypothesis. Even though I said fewer Girl Scout cookies up here, for simplicity's sake, we're going to ask whether the number of cookies at time 1 equals or does not equal, as a research hypothesis, the number of cookies eaten at time 4. Alright, step 1 is complete. We have step 2 now. Our alpha is 0.05. Step 3, we need to compute the required and the appropriate statistical tests. So let's go down and go back to our diet study. Once again, you know the data set, so you don't need to familiarize yourself with it. Let's click on Analyze. Once again, you'll go to Compare Means, and finally, you'll go to Paired Samples t-test. Now, this dialog box will look a little bit different, but that's okay. You simply put the two variables that you want to pair next to each other. So, if you scroll down here, you're going to see the number of Girl Scout cookies eaten at time 1. And we're going to compare it to the number of Girl Scout cookies eaten at time 2. So this is going to take the essentially the correlation between or within individuals into effect into the formula in the equation. And you don't really need to know that for the purposes of this course, the math that is, but the procedures are more important. So you click on OK, and you have our paired samples t-test. First thing you want to look at here are the sample statistics. So you have the number of Girl Scout cookies eaten at time 1 is 10.81 cookies. Number of Girl Scout cookies, the average number of Girl Scout cookies eaten at time 4 would be 9.87. Is there a difference there? 1 cookie less? Could be close. We have our standard deviations here as well. So you scroll down to the paired samples t-test here, and you want to look for your t-value, your degrees of freedom, and your significance. Your eyes directed here should tell you that there is indeed a significant difference between the number of Girl Scout cookies eaten at time 1 and time 4. So all you have to do now at this point is write it up in APA format. So the procedures are the same that you've seen before. We have our test, paired samples t-test. We have our t-statistic, our degrees of freedom, and our p-value here. And finally, we have our means and standard deviations as well. So you'll want to say something like this. A paired samples t-test was conducted to evaluate whether participants ate a different amount of Girl Scout cookies after a special diet. The test was indeed significant, with a T of 15 degrees of freedom equaling 2.457, and the p-value is 0.027. Participants at time 1 who ate 10.81 cookies on average ate significantly more Girl Scout cookies than at time 4, when they ate 9.88 cookies. I think I'm going to go get some Thin Mints now. Have fun with your workshop 4, maybe workshop 6, I forget which one we're on, and let me know if you guys have any questions.